remember in the last topic, we talked about entropy when we related entropy and enthalpy with the Gibbs free energy, and this was the equation here which you can see, where delta G is equal to delta H minus T delta S. So, here you can see that the Gibbs free energy is related with entropy along with change in enthalpy through a mathematical relationship. Now, let us go a little bit deeper into this relationship to really understand the very concept of entropy. If you can see this equation, have you ever thought that why there is minus sign here, that is delta G minus T delta S? What does this minus sign mean? I mean, it could have also been delta G is equal to delta H plus T delta S. The minus sign mean that the part of the energy that is useful is that part which has subtracted entropy from it, because entropy refers to what? Entropy refers to the disarray, the chaotic nature of a system, disorder of a system. So, of course, if something is contributing towards disorder, it cannot be used as useful work. That is why we subtract the entropy from the free energy, from the energy rather, to really make use of that energy for useful work. Fine. So, for instance, if you see here a reaction which is giving energy to the system or to the environment rather, and as a result of this the environment is undergoing more and more chaos, because temperature of the environment is increasing. Fine. And as a result, in this way we can say that the entropy of the environment is being increased because of the heat which is being generated by the system. That is why we cannot make use of that heat, because it is leading to the change or increase in the entropy. There is another way of looking at it. If you see the very mathematical definition of entropy, it is delta S is equal to delta Q by T, where delta Q refers to the heat energy. So, it means that delta S, that is change in entropy, is directly related with the heat energy. More the heat energy, more will be the entropy, and you can see here this figure here also, that you can see a system which is composed of, let us say, molecules which are very uniformly arranged, and once its system is increasing the heat of is somehow releasing heat. As a result of that, what will happen, that the molecules kinetic energy increase tremendously and they are chaos. So, here you can see they are in a uniform, very I mean smoothly placed condition, and here they are in a chaos. This is entropy. So, the energy here being given to the environment is leading to this increase in entropy, because now the molecules have many more possible states which they can acquire. Fine. But then you can ask questions, sir, what is this meant by this T then? Why it is in denominator? Why temperature denominator? It is a little bit difficult to understand. Students do not usually focus on it because they can't understand it. So, T is in denominator because, and you can think it intuitively, if something is already very hot and there is so much chaos, now any change in the temperature will not have that much effect on the chaos. But if something is cold, and if you give a little bit of temperature, the chaos will be much higher. So, that is why the T is in the denominator, that it will be inversely related with the increase in entropy. Fine. There is a third part also, that what is life? You see what is happening in cell. In cells, we see many organized type of functions cell is performing. They are very highly organized. That means the entropy of this cell is much less. For instance, this is the animation of the DNA replication, highly organized activity. Similarly, this is the animation of protein synthesis, again highly organized activity. But again, this organization, does it mean that life is contradicting the second law of thermodynamics, which says that entropy of the universe is always tending to increase? No, sir. The decrease in the entropy of the living system is at the cost of an increase in the entropy of the environment, of the surrounding. Why? Because the living things, while they are performing function, they also release heat, and that heat is leading to increase in entropy of the environment. So, some brainstorming. How the entropy of the outside environment is increased? What actually is the mechanism behind it? Why your bodies do not feel hot? I mean, if it is producing so much heat, why they remain very normal? Why don't they get hot? Why don't they get so warm? And why the entropy of the body will decrease? Why it has to decrease? And finally, similarly, likewise, why at all the entropy of the environment should increase? Why there is a need for the environment's entropy to increase?